afternoon, Cornerstone. I'm Sydney Honeycutt. Welcome to math. Today we are learning lesson 15.3.
Thank you, Sydney. Okay, we're going to go over one of the assessment questions that students had problems with, which was number 5. So let's just go over this really quickly. What we're trying to do, of course, is to clear the fraction of equations, or the, that makes sense, clear the equation of fractions, and we'll go from there. All right, so what are we going to multiply by? What's our least common denominator?
3x plus 4.
Okay, so we're going to multiply by 3 times x plus 4. And again, for simplicity's sake, I just go ahead and multiply every single one of them by all of those, because then I get to kill the twins, as we so lovingly say. So we're killing everything that matches, top and bottom. No, sorry. Okay, and we're going to get 3 times 15, which is 45. And then we just have 1 times x plus 4, which is so nice. And then we get 2 times 3, which is 6. 6 times x is 6x. Okay, and then 6 times 4 is going to give us plus 24. All right, what do we do at this point?
You combine like terms.
Okay, we're going to combine like terms. So we're going to have x plus 49 equals 6x plus 24. Okay, now what?
Now you move the x's on one side and the regular numbers on the other.
All right, so I'm going to move this single x over here, and I'm going to subtract 24 from both sides. So we're going to end up with 25 equals 5x, and then x equals 5. Okay, so, and of course you could plug it in. You get lovely answers. 15 over 9 plus 1/3 equals 2. And we can add, make this into 3 9s, and then we would get 18 9s, which equals 2. So it does work out. It's just not a happy thing. Okay? All right. Any questions on that one?
Negative.
Negative. Very good. Okay. We're going to look at today's lesson, which doesn't look positively frightening until I put up the notes. Okay.
When do you take notes?
Not really. I mean, we're going to practice some problems. Basically, what's going to happen is you're going to do the same thing you've been doing in lesson 1 and in lesson 2. Okay, so lesson 1 you did a lot of proportions, remember? And then lesson 2 you did the clearing the equations of fractions and solving the equations. In this lesson, you'll do some of those same things, but you're going to end up with this type of problem, a quadratic, where you have an x squared, okay? Or maybe you'll have more than one x squared. So once you get that situation, then you're going to have to solve it using the methods we learned in chapter 13. Okay, and when you solved quadratics, you learned how to factor to find answers. You learned how to do the square root method. You learned the completing the square method, and you learned the quadratic formula. Okay, here is, using the quadratic formula. You can use any one of those methods, even graphing if you would like. I can't imagine that would be your typical solution. But basically, you can just use any of those methods that you learned in chapter 13. But it does make for some very large looking problems. Okay? So let's go on. We're going to just try a couple problems. And they look tame enough from the outset, but they're definitely more difficult. Okay?
Is this like a proportion?
This one is a proportion, okay? So let's try the proportion. Again, you're free to write on your whiteboards, but you might also want to take notes, or you might choose to take notes instead, just because these are more difficult problems. Are we doing okay with the filming?
Yeah, it's just you can't really see the
I'm just trying to see if you can zoom at all. Do you know if you can?
Yeah, maybe we might have to put it closer. Might be on the side. Or just somebody write it down and
Is it
put it in front of the
side?
thing. Yeah,
Keep
not a
going
bad
to the
idea.
camera.
I can do that.
I think it's fine. Cause
I can't see it,
From-
but
from up here, it's amazing.
wait, we can.
Is it clear enough?
Yes.
Okay. All right,
Oh, yeah,
let's
you
look
can
at
see
this
it.
one.
Yeah.
Okay.
You can't really solve it. Well, I mean,
You can
This
solve
right
it,
here,
but
though.
you're going to end up having to also do something else. And that's sort of the point, okay? So for those of you who like using a lot of paper for your math problems, you will be happy, because these are long. Okay? All right, so we're going to cross multiply. All right, and when we do, we get x times x minus 4. And on the other side, we get 4 times x plus 1. This is the side that's the problem, right? So we have to then distribute the x, and we're going to get x squared minus 4x. And then we get equals 4x plus 4. Okay, now let's just go ahead and plan on using the quadratic formula, and then I know I'm going to move everything over to the left-hand side. Okay, so I'm going to add, or excuse me, subtract 4x from both sides. I'm going to subtract 4 from both sides, and I'm going to scoot up here because I've run out of room. I apologize. We get x squared minus 8x minus 4 equals 0. Okay, is everybody in agreement? Okay, and I'm pretty sure we don't know any factors of -4 that are going to add up to a -8. So we can't factor. So we're really pretty much stuck with either completing the square or doing the quadratic formula. Do you remember the quadratic formula?
Yes.
It's
All right.
Negative b
Negative
plus or
b
minus
plus
square root of negative b squared plus minus 4ac over 2.
Perfect. Okay, and what is a equal to? And b
Negative
and c.
-4.
Okay, so let's plug it in. So negative b is going to be positive 8 plus or minus 64 minus 4 times 1 times -4. Okay, all over 2 times 1. Okay, so what is 64 plus 16?
64 plus 18.
Okay, so that's not a very pretty
It's 80.
number, is it?
Wait.
Okay, over 2. Sorry, don't tell Ellie I said that. Okay, so we get 8 plus or minus the square root of 80 over 2. Can we
16. Pull out a 4.
pull out a 4?
Yeah.
Okay.
And then leave in a 5.
Okay, so 4 square roots of 5 is what we're going to get over 2. Okay, and then what can we do with this?
Cross out the 2 and make the 8 a 4 and then 4 a 2.
Okay, so we can basically divide everything, just kidding, everything by 2. So we end up with 4 plus or minus 2 square roots of 5.
Is that like an easy one?
Yeah.
No.
They're not necessarily much more difficult. It's just that instead of a proportion, it's got to be a fraction, you know. And the answer is unpleasant at the end. So to check your answer, for instance, if you tried to put, you know, 4 plus or minus 2 square roots of 5 minus 4, you'd end up with 4 over 2 square roots of 5 equal, you know what I mean? It would be just an ugly answer, but it is possible to check it. In fact, I think I have tried checking it, and it does work, but it's just not working. Okay? Any questions on that one? You like it so far?
Yes.
Yes, good answer, Luke. All right, so let's try.
Wait, oh no.
Oh no, sorry. Just pretend that it's all okay, and I have it written somewhere so you can get it if you want it later, Sydney. Okay, all right, so 3 over x, just kidding. Sorry about the black smudge looking thing on the side. 3 over x plus 1 over x plus 2 equals 1, okay? So this is the kind of problem you were doing Wednesday and Thursday, or Thursday at 11 o'clock. Just kidding, only if you did track. Okay, so what is our greatest or least common denominator?
Wait.
So in other words, what do we have to multiply?
X times x plus 2.
Okay, so x times x plus 2. Okay, and again, I know that I'm a little redundant, but I'm going to just write it all out, because then I'm pretty clear what I'm doing, and I get to kill off things, which makes me happy. Okay, in a nice Christian way, of course. All right, so now we're going to have distribute. So we're going to get 3x plus 6, okay, and then we have x, just x, correct? Equals, and here's where we get our nice quadratic form. Okay, we're going to get x squared plus 2x. All right, so what's our next step?
Move
To
everything
subtract
over left.
x squared and
Oh,
2x.
yeah, combine like terms.
Okay, so we're going to have 6 plus 4x equals x squared plus 2x. Okay,
Subtract 2x.
okay.
Both sides.
And we can subtract x squared. Okay, so we're going to end up with negative x squared plus 2x plus 6 equals 0.
Yeah.
Okay, so again, I'm going to have to scoot over here. We'll use the quadratic formula.
Yes.
Okay, all right, so what is a?
1. Negative 1.
Negative 1. B
2.
and C.
Negative 6.
6.
6. Okay. All right. So negative B
And
plus or
negative
minus
2.
4 minus 4 negative 1 times 6 all over negative 2.
Wait, it's times negative. Instead of times negative 6. Never mind.
No, it is positive. Okay, but our A is negative, so it's okay. All right, so we're gonna have negative 2 plus or minus, and we're gonna have 4 plus 24. Okay, another unpleasant answer. Okay, so negative 2 plus or minus the
So
square root of 28.
So you can take out 7 and 4, and then you get 2.
Okay, so we're gonna get negative 2 plus or minus 2
2
square roots of 7
Yeah.
over negative 2. Now what are we gonna do?
Take, subtract.
Let's see the negative 2s.
Okay. These are very unpleasant. Okay, so they all become 1s, right? So,
So it's negative.
and the, yeah,
Do you
it's
have
kind
to
of
add
awkward.
the 1?
You do have to have the 1. You end up with, just kidding, this. Okay, and that really is the correct answer, but it is kind of awkward because the way, we had that negative on the bottom, and so we're sort of taking a negative 2 out of everything. Well, when you take a negative 2 out of something that's being added and subtracted, it just doesn't matter because it's being added and subtracted anyway, and so it's sort of negating the fact that that's a negative, okay? So just 1 plus or minus 7. You guys good with that?
Wait, do you want to erase it?
I won't erase it. You want to try? How much time do we have left?
We get out at 20 today.
Okay.
We have 15 minutes.
All right, we're doing okay, I guess. Do you want to do one more of those, or do you just want to trust that they're all pretty much like that?
Let's
Trust that they're
Yeah.
pretty much.
Okay, then we can spend more time on the word problems.
Yes.
Okay?
They're
All right,
word
Sydney,
problems.
can I take it?
Yeah.
Okay.
I didn't
All right,
get
so
that.
what we're going to do is we're going to look
Wonderful.
at some of the word problems. You might, if you have your book with you, you might want to look at the book so that you have a better idea. We're going to look at 15.3,
Can you grab me one, Luke?
and we're going to look at number 6. Okay. And we'll be nice. We'll probably do number 6 and hopefully number 7. And if I were you, I would do these on paper and just consider that, you might even start your homework lesson and just start with number 6 and put number 6 and 7 on your homework, and then put 4 and 5 underneath it. Okay? Does that make sense?
Yeah.
So that you have it intact, because we're going to do 2 homework problems. All right? Everybody hears me. No unfair advantage, except the fact that you guys are actually in class. So we'll do 2 of the problems because you will also be doing set 3, so you will have an opportunity to practice, but this way you'll have something written down to use as an example.
So we can just copy it down when homework comes, just write it down.
I would just pretend that you're starting your homework and that you're starting with number 6 and 7. Just write it in your spiral now as if you were doing your homework, and then put 4 and 5 underneath it,
Oh, so this
or
is-
on it, the next page. I don't care if it's out of order. Okay, does that make sense?
Yes.
So in other words, we're doing your homework right now, except for those of you who are coloring on whiteboards or texting on your cell phones. Okay, no one would do that in algebra. That would be foolish, crazy talk.
Do what?
Okay, nothing. All right. Oh, I'm sorry, reading Harry Potter.
Oh,
Oh,
do such a
no,
thing.
that would be crazy talk. All right, let's look at number 6 in your book. We get to deal with obtuse Ollie again and acute Alice.
I remember him. In
Yeah,
the-
yes.
I don't remember him.
You
He's a bad
don't?
boy.
Isn't this
You guys
15-4?
didn't remember Gallon Man.
15.3.
Mistaken.
What, dear?
Do you remember
Go.
Gallon Man?
Gallon Man?
Gallon Man.
Nope.
Kai's getting out of her seat.
Really?
Go back to
He's
normal.
crawling over the ground. Film Kai.
Please, yeah, do not film me. Okay.
You should film
Okay, obtuse Ollie.
Oh, that poor bug.
Is he like fat or something?
There's one on the floor right here, too. Quick, quick, we're wasting their time. There's one right there by
He's wasting their time.
Emily's
Are
foot.
Are you gonna use it, Emily?
What?
That book.
No, that's not mine. Am I the only one that
I think
remembers
it's
Gallon
George's,
Man?
or he was using it.
Go.
It was this guy.
Okay, it takes obtuse Ollie working at a steady rate 80 minutes to wax his car. Wax on, wax
Wax
off.
off.
Okay. Acute Alice can wax the car in 60 minutes because she's a girl and she's acute. Okay, find out how long it would take them to do the job working together by answering each of the following. And the book walks us through the problem. Okay, what fraction of the job can Ollie do in 1 minute?
Do you have to do A, B, C, and D on this one?
Yes, but it'll help you, Luke. You won't hate it. Just kidding. All right, so this is number 6A. Okay, so Ollie can do the work, how much work in 1 minute? If he can do all of the work in 80 minutes, then how much work can he do in 1 minute?
What?
1/80th. Just trust me on this one.
180.
Alright.
Yeah.
At least there's no.
Oh, in 1 minute.
Okay, 1 minute usually takes him 80 minutes, okay? And then Alice can do, how much would she do in 1 minute?
160.
1/60th. Okay? All right, so for letter B, it says, suppose that X represents the number of minutes that it takes them to wax the car if they work together. So write expressions that indicate this, okay? So how much work can Ollie do in X minutes? X over 80, okay? Because we don't know how many minutes. And how about Alice? X over 60, okay? All right, now they want us to write an expression, an equation that expresses the fact that the sum of these two fractions, okay, the sum of the two fractions of the job done by Ollie and Alice during the X minutes is 1. Okay, in other words, it equals one whole job done. Okay, so for letter C, you're simply writing X over 80 plus X over 60 equals 1. Okay, it just means one job is done. All right, so for every work problem you get, you're basically setting it up this way. So solve the equation to find out how long it would take them. So what are you going to do to solve this for X?
Find common denominator.
Okay, so what's the common denominator?
That's a great question.
480? 240. Okay, so if we multiply by 240, we're going to get 240x over 80 plus 240x over 60 equals 240. Okay, so 80 goes into 240 how many times?
A couple.
3.
3. Okay, and 60 goes into 240 how many times?
4.
4. Okay, all right, so now what do we do?
Add like terms.
7x plus
Equals 24.
Okay, and then we're gonna divide by 7. Good. So x equals what?
It's like a decimal.
It's gonna be a decimal.
Does that mean 31?
It's a little bit more than 31.
What page is this on?
It's 34.28. Let's just say 34.
Okay, so it's 34.29 if you round it. And I think, does it tell us to round it? No, it just says to, okay, to solve the equation. So you could round it, because I don't really know what 0.29, or you could say 34.5 minutes, you know, something like that would be fine. Okay? All right, everybody good?
Okay.
No, not really. Can we do another one?
What?
Can we go over another one?
Yeah, we're gonna go over the next one, number 7. It's a little bit different because it's kind of a distance problem, and I know you guys all enjoyed doing those back in chapter 7.
Is that where we had to do like the lines and the cheetah runs and what was that
Yeah.
weird thing called like an alpaca or whatever?
Yes.
Remember that?
Impala.
Impala.
Alpaca? Alpaca?
That'll work.
It was close.
And Sydney's love is
Wait,
close.
but there is something like a alpaca. It is. That's what I.
All right. So, do you guys know who Miss Marple is?
No, I do not.
No.
Miss Hootie?
What? No, not Miss Hootie. Miss Marple. Okay, Miss Marple is. If you ever read any mystery novels, she would be in the like Agatha Christie would use Miss Marple, and she's like this old lady who would solve the crimes.
Nancy Drew is
So, Nancy Drew is not an old lady.
yeah, she's
She
young.
should be old by now, but
She should be like really old.
okay. Sorry about their laughter. Okay, all right. So Miss Marple rode her bicycle from her house to Inspector Craddock's, at an average speed of 15 kilometers per hour and back home again at an average speed of 10 kilometers per hour. Find her average speed for the round trip by doing each of the following.
I don't even know how to do this.
Is 15
Right, without
kilometers a
being
long way?
fractions.
What?
Is 15 kilometers a long way?
Is 15 kilometers a long way? No.
Is it like
How much is a kilometer?
14 miles probably?
Half a
I know
mile,
that
almost half
like
mile.
a 5K race is a
Miles.
over 3 miles.
It's 3.1
3.1 miles.
So,
It's 5 miles.
so 15 kilometers
15
would be 3
miles.
times.
Oh yeah, 9 miles.
2, 6, 5.
Yeah.
Because
So it'd be about 9
That's not what I
miles.
meant, but.
On a bike, should be
Three,
about-
2, 3, 8, 4, 6.
Okay, so if you remember when we did our distance, rate, and time problems before, we used these little diagrams, okay, except that we actually drew the lines evenly. Okay, so she goes 15 kilometers per hour, okay, there. And then on the way back, I guess she must have had some coffee because suddenly she's going 10 kilometers per hour, okay? All right, and so we're going to find her average speed for the round trip by doing each of the following, okay? So for letter A, we're supposed to let x represent the distance one way in kilometers, representing the time, okay? So we're going to use this fact. It tells us this, okay? I'm not making it up. I'm not super intelligent. They're going to tell us that the time equals the distance divided by the rate, okay? And they're telling us that,
Yeah, with the Impala.
okay, they're telling us that the distance is x, okay? So for the way there, she's going x over 15, right? Okay, and the time on the way back is x over 10. Okay, so we get those two things, okay? And this is going.
Wait, time equals distance over rate. Wasn't that like, was that dirt?
Yep, that's dirt.
Wait, that would be T
That's
equals
real
D
dirt.
over R.
Okay, this is the original formula. Distance equals rate times time, or dirt, okay? And whenever distance is the thing being solved for,
it's
then you
like-
always multiply.
Got it.
But if we know the distance, then distance is always being divided. Okay, so in this case, to get t by itself, we're dividing by r.
It's like in
Okay.
science, we had to learn how to do that. It was really annoying.
Yeah, I know you did a lot of them in science. We're
We
doing
did a lot
okay?
of math in science.
Yes, and that will continue. Okay, Amanda, basic. All right, letter B. Okay, write an expression for the total time spent on the round trip. Okay, so how would you represent that? They're speechless. Okay, all right. This is the time going. This is the time returning. How much time for the entire trip?
It's
Over
X.
25.
X over 50.
Do the
X over
multiply
150.
Equals x.
How about
No,
just an
30.
expression?
Make it all together like 30.
Isn't it the going time plus the returning time equals the total time?
Yeah,
so
so like
it's-
make the denominator
So it's
30.
so it equals x.
Okay, it's not equaling anything right now. We're just writing an expression. Okay, now letter C, it tells us to find her average speed by using the fact that the average rate, and again, I'm not making this up, okay, the average rate equals the total distance. Like average, it's an abbreviation. All right, you guys are crazy. All right, I'm gonna scoot this up a little bit so we can see better. Okay, so the average rate equals the total distance divided by the total time, okay? All right, so what is the total distance?
We don't know.
25.
X
Long
over
years.
15 plus x over 10.
Well, let's see. They're saying that the distance is x. So that means from here to here is x.
Oh, just
Okay, and from here to here is x. So
No.
what is the total distance? 2x. Okay. All right, and what's the total time?
25.
Gigi, what's the total time?
X over 10.
Oh, very good. All right, so x over 15 plus x over 10. Okay? All right, and that equals the average rate. So what are we going to do from here?
That's C. Answer is C.
That is C. Except now we have to
Solve.
solve it.
Could you divide by x?
Okay, so what are we going to do? What are we going to do? Need to deal with this first, right?
Common denominator?
Common.
Okay, what's the common denominator?
30.
30, good. Okay, so we can have 30x, 30x.
So you come up with 15, 2x,
So we get 2x
and then
plus
3x.
3x. Okay, so now we have 2x over 5x.
And then 2 fifths.
Okay. Why am I getting weird answers? Oh, because it's not equal to anything. Just kidding. Forget that. All right, so we get 2x over the same thing, but because it's not an equation, we can't just kill off twins and things like that. We are still gonna get a common denominator, but what happens is
You put it to everyone.
what?
Do you have to like do it to every single one?
It just means that we're going to end up with 2x over 30 plus 3x over 10. So we end up with 2x over 5x, sorry. Okay. Common denominator 30, okay? Sorry.
Yeah.
So we get 2x plus 3x over
That's what I
30.
thought you were supposed to do.
Yeah, sorry, Luke. Should have had you up here. All right, so we're gonna, now we have to say 2x over 1 times 30 over 5x, correct? Yes, no? Okay. Our x's can cancel. What else can cancel?
5 and 30.
Okay, 5 goes into 36 times.
Yeah.
So we end up with 12, and this is kilometers per hour, which you can almost see. Okay?
Wait, what'd you do?
Okay, so we got a common denominator.
Yeah, well,
So we have 2x over
how'd you
5x.
make that 30 and 60?
Oh,
Oh,
I didn't. Thanks for asking. Okay, I did not. I just lied. Okay, so it's 2 times 6, just kidding, and our answer is 12.
Are we done?
Okay, now everyone has a permanent record of
This was for class.
Other way.
Other way.
In public.
No.
Yes.
Amanda. Okay. Wait, we have to give Mrs. Honeycutt in the window.
I have to announce. Thank you for watching. Tune in next time.
Actually,
Or just come to class.
Yeah, you can do that too.
That works
we're
also.
live studio audience.
All right, thank you.
Yay.
Now.
Wait.
Done.